So this is what it all comes down to, the takeaways and the parts that may still be questionable to you. Please go ahead and complete these sections. I will move on to the final checkpoint. Let's see what our checkpoints are for today. So of course, first of all, we can now determine the internal force and bending moments for distributed loads. That was the entire purpose of this lecture. I believe you can now apply that. You also know how to find all significant values that are necessary to really completely represent the internal forces, and really what I should highlight here is the completely, right? So you cannot forget any one of those, because otherwise the communication between different engineers is not complete, but you know what you need to do, so you can check this off as well. Then we talked about specific load cases, and what I mean by that is, for example, a concentrated load or an evenly distributed load or any other thing that then produce certain characteristic shear force and moment diagrams. So these diagrams really depend on the load case, as you have seen, and therefore you can now relate these to each other. I think that is where we spent a lot of time in this lecture on, and so we can easily check that off. So now you also understand how the shear force diagram relates to the bending diagram, right? So there's a relationship between the shear force diagram and the bending moment diagram, and that is something we discussed at length in this lecture, so I'm sure we comprehend that as well. Ultimately, you were able to use these methods and also to use differential math, if you will, because we effectively integrated and differentiated so that you can determine the internal force diagrams. So you can use really every tool in your arsenal to arrive at these diagrams. So we can check that off as well. So that now completes our final checkpoint, and we are ready to move on to the homework. Let's take a look. So this is where the fun starts. We are now drawing internal force diagrams for distributed forces. As you can see, all 6 problems have distributed forces in one way or the other on them. Let's take a look step by step. The first one is a simply supported beam with just one evenly distributed force on that. That is halfway, or a portion of it is loaded and the other portion is empty. And I'm pretty sure you can easily now draw these diagrams. There's not much help that you need from my end to do that. Here it becomes a little bit more interesting. We now have W1 and W2 acting over the entire length. And just one word of caution here. So number 1, your W2 of course may be larger than W1. Then you have to draw W2 a little bit higher. But either way, the concept that I'm going to show you now applies. So the way I like to solve these problems is actually by drawing a line through here and then pretty much treat all this with the same type of, in my case here, W2, and then I apply these here on top of it and this here on top of it. Notice that it's a symmetric system, so that tells you a lot. There's many ways to solve this, and of course that's up to you, but again, I prefer to unify it so that I have one continuous load on there and then have a little bit additional load somewhere, but you may use other methods as well. All right, so now we have a beam here that actually carries concentrated forces, which are symmetric by the way, and a distributed force. So please think about what impact they have on your shear force diagram in combination with the distributed force. And then also, of course, on the moment diagram, notice it's symmetric in length as well, or like the beam is symmetric as well, so CAC. And I believe this should be a walk in the park for you now. Of course, practice makes perfect, but I wish you good luck with that problem. Let's take a look at the next one. So here we now add a concentrated moment to the system, which of course you know how to deal with as well. In fact, this problem probably looks very similar to problem A. So there's not much that should challenge you here, except we want you to be exposed to this additional challenge and how it looks in your shear force diagram and in your moment diagram. Therefore, let's move on to the next problem, which now is a cantilever. And yeah, we didn't solve cantilever beams, but of course you can pull the knowledge together from different lectures and from what we talked about before. Here we have an evenly distributed force sitting on top of the cantilever that's supported on the right side. And we also have a horizontal force acting on it. So that should lead to some fun with the normal force diagram. All right, not much more to tell you here. Let's move on to our last problem, which is a cantilever beam that's now supported on the left side. It has a sloped force, which means we have a horizontal and a vertical component. And be cautious here because you're actually pushing up with that force. So that, of course, has a specific impact on your shear force diagram. Then you also have this non-evenly distributed force, which slopes down from W4 here at the very far left to 0 here on the right over a length of B. But I'm sure with everything we talked about in this class, you can easily solve this problem. If not, if any of these problems really causes some trouble or you have a challenging time with these, that is not a problem. In fact, that's why we're doing it. We want to be challenged in our homework and not in our exams or in the real world. But if that is the case, please go ahead and just split up your beam into more cuts. So for example, if this beam here had a length of 10 meters, I would probably make a cut at 2 meters, at 4 meters, 6 meters, 8 meters, and 10 meters, just to give myself enough exposure to these cuts and to connect the dots properly. And of course, the more you do that, the more you will learn throughout the different problems as you go through them. And probably for the last one, you have to do a minimum of cuts at that point. And that is really the point you want to reach. So my advice to you is do as many cuts as you can on the homework so that you learn as much as you can and be super fast in the real world and in your upcoming exams. You will see that every minute you spend right now will pay off a lot later on. But for now, I wish you good luck with your current homework. And I'm pretty sure that if you made it to this point in the class, you have what it takes to solve this. So don't doubt yourself. Just keep practicing. I wish you good luck with that. I will see you in the next lecture. Until then, stay safe.